video is for the function Frayer models. So with Frayer models, we're going to do these for each unit, and they're going to cover kind of the main term or an important term or vocabulary word for each unit. So with these Frayer models, we're going to write a definition. We're going to talk about facts and characteristics of the term, and we're going to list examples and non-examples of the term. Okay, so for function, the definition is an input, output relationship that has exactly one output for each input. Okay, X's can't repeat, Y's can. X's are input, Y's are output. So some facts and some characteristics. Functions have names. So functions have names. So f of x is one of the most common ones. So again, we read that as f of x. Yes, I write my f's funny. Then we've got g of x. G of x is how you pronounce that. So this right here is just a placeholder. Just a placeholder. And really, we could swap these names out with a y. It's the output. It's a collection. A function is a collection of things. So we're going to do a lot with functions this year. So examples. So I'm going to use mappings for my examples. So input is typically on the left. My input values are going to be 6, 5, 2, and 1. Outputs are typically on the right. They're going to be -4, -1, and 0. And so a function would have each x matched up with a different y. Now, two inputs can go to the same output. That is okay. That is still a function. When it becomes a non-function, not a function, so a non-example here. My input here is going to be 1, 2, 3, and 4. My output is going to be 9, 8, 7, and 6. So the 1 is going to go with the 8, the 2 is going to go with the 7, the 3 is going to go with the 9, and the 6. And immediately that's not a function. If the 3 starts walking in 2 different directions, it is no longer a function. And then we'll pair the 4 up with the 6.